Hey guys, so today we're looking at our first section of Algebra 3 notes, and it's a lot of review, so let's just go ahead and get started. Uh, I'm going to preface this lesson with it's a really, really basic review, alright? So I'm going to go over like the types of problems that this lesson will cover, and if you feel comfortable with that, then by all means you can just skip straight to the homework, alright? So the first thing we're going to be doing is going over like just graphing two variable equations on a coordinate plane. And what I mean by that is like, can you use like an XY table? Wow, my handwriting is just really not good. Um, yeah, there we go. Can you use an XY table given some function and generate XY values and then graph them on a graph and then, draw your shape? If you can do that, that's, half of the lesson. Another half is finding x and y intercepts. So without a calculator, you find x intercepts by plugging in 0 for y and solving for x. To find y intercepts, you plug in 0 for x and solve for y. That generates your x and y intercepts. You plot them. If it's a straight line, you just draw straight through, and if not, then you'd have to use this in order to draw the shape, right? That's pretty much all we're doing today, along with a couple of other basic things. So by all means, if you think you're strong in math and you haven't forgot too much, just skip to the homework and see if you can do it, and if you can't, then you can come back. All right, so let's get to it. The first thing, real basic, just plot these points on a coordinate plane, right? So these things here are ordered pairs, and this is the x value of the ordered pair, and this is the y value of the ordered pair. This is the x-axis, and this is the y-axis. So this is -6 on the x-axis, so -1, 2, 3, 4, 5, 6, and then +7, so -1, 2, 3, 4, 5, 6, up to 7. Right there. All right, so that's that. And then we've got the next one. We've got 3, 1, 1, 2, 3, 1. Then we've got the next one, 0, 7, 0. That means not going left to right any. And then 7. Should be right there. All right, then we've got, man, my back hurts. -2, 9. That's going to be right here. That's in lovely whatever color this is. And then we've got 4, 0. So that's 4 on the x-axis, +4. 1, 2, 3, 4. And then 0 on the y-axis, which is just on the axis here. So that's that. I mean, every time I shade, my microphone is wiggling back and forth. Hopefully you don't notice that. I doubt you do. Yeah, whatever. All right, so then we've got 5, -5. So that's going to be 5, 1, 2, 3, 4, 5, -5, 1, 2, 3, 4, 5. There we have it. All right, basic plot the coordinate stuff. All right, hopefully in Algebra 3 you don't have a problem. You don't have a problem with that. Hopefully. Now, this is something that you're much more likely to have forgotten. So match the parent functions to the type of graph that it is, or the description, right? So we've got line, parabola, V-shape, and then we've got this squiggle here, and then we've got this other little squiggle here, and then we've got all these equations, these functions. So, if you think you've got what it takes, go ahead and match one of these to one of those, including the shapes. And then they all have matches. And pause the video and go. Excellent job. I'm sure you got the correct answer. Unless you didn't pause, and then you're a loser because you're not participating. So we've got y equals x cubed. Looks like this. Looks like this little squiggle. And if you remember last year, I know like almost all of you were in my class last year, we had like end behavior. And I'll briefly go into this. Like an odd degree polynomial that's positive will start down and end up. So that's right here. Is this ringing any bells? Even degree polynomials, like this one here, will start up and end up if the leading coefficient is positive. And I remember that I had a bunch of my students like having a list, talking about leading coefficient if it's positive or negative, and then degree if it's even or odd, right? And then we had these shapes, right? That kind of thing. If that's over your head, don't worry, we're not there yet. So I'm just trying to jog people's brains. So then that means this one here has to go to this one, because x to the fourth power has got multiple bins in it, and it's going to start up and end up. So it's going to look like this. It's got this little dip here. See that? Then we've got standard, like super traditional sort of basic function types, which is y equals x squared, y equals x, and y equals absolute value x. Y equals x is your standard line. So this one goes to line. So let's go ahead and do that. This one goes to a line. And then this one here, if I can figure out how to erase, that would be great. How do we erase all this confusion? Oh, no. This will do. I just don't want to be confusing here. Perfect. Not everything's got to be perfect. All right, so, but that was actually perfect. So, oh man, this microphone. I'm a professional, I swear. So y equals x is a line, and then y equals x squared is a parabola. And then y equals absolute value of x through the process of elimination is a V shape, and it absolutely is. Okay. Parent functions and transformations of parent functions are something that we cover a lot in Algebra 3, just saying, right? So, graphing basic two-variable equations. Now this is like identify the parent function and the transformation, right? That's how we're going to do it. And so we can either use a table of values, as it says here, or we can identify the parent function and the transformation. So I'm going to do it by parent function, and then I'll prove that I'm correct by doing the table of values. All right, so the parent function for this example is the most basic type of x squared function, and that's going to be y equals x squared, right? That's the parent. If I can write. I feel like I don't know. I write poorly. So I know that y equals x squared looks like this, right? We just talked about that. And I also know that a plus 2 at the end here makes our graph go up. Wow, that is very hard to see. That's why I typically have a black background, but whatever. So this is going to go up 2. So on your parent function, the vertex of your parabola is the origin, like that. But ours is going to go up 2. So our vertex is actually going to be here at 0, 2. And then it looks like this. There's been no other transformations, and so you just go ahead and plot it. And you don't have to be super precise. I'm not looking for like great accuracy here. And if you don't believe that this is what it looks like, then just plug in x values and see what you get for y. So let's plug in 0 and see what we get. Well, 0 squared is 0, plus 2 is 2. Oh look, surprise, surprise, that's exactly what we should get. I also imagine that if we plug in 1, we're going to get 3. If we plug in -1, we should get 3 again. So let's plug in -1. Well, a -1 times itself is +1, plus 2 is indeed 3. Plug in a +1, and then you get 1 times itself is 1, plus 2 is 3 again. What are the odds? So that is what this looks like. And if you're ever in trouble with forgetting parent functions, then just look at a table of values or use a calculator if I'm allowing it. All right, so here, this parent function is y equals absolute value of x. I understand that I'm transitioning between examples quickly. if that's a problem and you're writing down notes, first off, good job. Writing down notes is great. I encourage that. But second, you can just pause the video. All right, just pause it and then write down the example and then resume. All right, like you have that ability. Right, this is a choose your own adventure style lecture. Right, if you already know how to graph this, just skip this. Don't listen to me rattling on about things you already know. So the absolute value of x is a v, right? Like a straight v, and the vertex here is again on the origin, like it was for the parabola. So that's what the parent function will look like. The 2 in the front, however, anyone know what transformation that does? Any takers? Don't raise your hand and ask me. Just tell yourself. Who knows what I'm doing? All right, so hopefully I'm just sitting at my desk not doing anything. That would just be so great. I'd just be lazy. But anyway, I'm just kidding. For any parents listening to this, I'm a super diligent worker. All right, so the 2 is responsible for vertically stretching the graphs, and we call that a vertical stretch by a factor of 2. All right, that's what that is. VS BFO 2. So what that means is that here's the parent function. All right, here's exactly how the parent function looks. Just like this. Concentrate. Got it. All right, so every one of these spots on the graph, any of these little anywhere on the graph, right? A vertical stretch takes these points and vertically tugs on them up twice the value that they are currently. So it should cross, the parent crosses 1, 1. But if you take this point and you drag it up twice as high, well, it started at 1. It's going to get pulled up to 2 because that's twice what 1 is. So then this next point is at 2, 2. It should get pulled up as well. But like 2 times 2 is 4, so it should look like that. And then the next one is 3, 3. The y value is 3. That should double when you vertically stretch it by 2, by a factor of 2. So it should go up to 6. So 3, 4, 5, 6. So it should look something like this. Well, that was, man, I can just tell that I've not taught a real lesson on a smartboard in a long time. So I'm going to predict that this is what's going to happen next. All right. And let's see how correct we are. Let's plug in 2 and see what happens. So plug in 2, and I'll plug in everything with the this, I'm not good with colors. Whatever that color is, purple or something, I don't know. So we've got y equals 2 times the absolute value of 2. Well, ladies and gentle people, the absolute value of 2 is 2, and 2 times 2 is 4. Surprise, surprise, that's exactly what we got. All right, and you'd find this if you just keep plugging in values, you will get this. Plug in 0, and you will also get 0, because 0, the absolute value of 0 is 0, and then times that by 2, it's still 0. Okay, hopefully we get this. Anyway, let's move on. So, what in the world? Just ignore this. Yeah. Okay, whatever. Whatever. We're doing it live. So, finding intercepts. So to find the x-intercepts, plug in 0 for y and solve for x. To find y-intercepts, plug in 0 for x and solve for y. Simple as that. Now, here's the explanation as to why you are allowed to do this, and then this should help your understanding in math. So, say you've got this equation here, y equals 2x minus 4. Well, x-intercepts, and I've talked about this, I've given this same talk to you same students, most of you, in Algebra 2, so let's just try to remember, right? So, x-intercepts are locations where your graph crosses the x-axis. So here's the x-axis, right? So there's your x-axis. Imagine some points on the x-axis like here, or here, or here, or here. Those are all intercepts, assuming that there is some sort of function that crosses them, right? So the ordered pairs for this is like -8, comma 0, -2, comma 0, 5, no, wait, 1, 2, 3, 4, comma 0, and 9, comma 0, right? These all have in common this 0 here, right? This magical 0 right here. And there's a really good reason for that, is because they all have 0 for their y values. Otherwise, they're not touching the x-axis, right? So every x-intercept has 0 for its y value. And we can use that to our advantage. If we know the y value is 0 for all x-intercepts, just make the y 0 and find out what that x is. That's all you do. And the reverse is true for y-intercepts. So all the y-intercepts, like all of these y-intercepts here, anything that it's crossing the y-axis there, and yeah, let's make that look. There we go, professional. All right, so any of the ordered pairs that would touch the y-axis have zeros for their x pieces of their coordinate, of their ordered pair. Yeah. So what that means for us is that to find y-intercepts, if you plug in 0 for x, figure out what you get for y, and that is your y-intercept. All right, so let's go ahead and do that. So x-intercepts. Oh, dang. I've got to erase all this because it's going to be confusing. Nah, I'll decide. I've decided not to. So, you want to plug in 0. Let's find x-intercepts first. And sorry, I write crooked. It's because I'm a crippled left-handed person. Right? I gotta like really swivel my hand around. So we've got x-intercepts. Plug in 0 for y. So here's our equation. I'm going to plug in 0 for that y right there. So 0 equals 2x minus 4. And then solve for your x. So I want to add 4 to both sides. You know, like your standard solving. You've got 4 equals 2x. Then you divide by 2. And then you've got that x is equal to 2. So that means x is 2 and y is 0. Remember, you plugged in 0 for y, so it's got to be 0. So that's your x-intercept. Man, now I'm really wishing I'd erase this. Man, let's just, yeah, I know. You don't have to tell me. I'm aware. Yeah, okay. All right. That was why I was worried about earlier. Whatever. So, 2, 0 is right here. And there's all these other dots. And this is... Never mind. Alright, so let's find y-intercepts next. So for our y-intercept, you want to plug in 0 for x and solve for y. So I'm going to plug in 0 for this x right here. Okay? So we've got y is equal to 2 times 0 minus 4. Wow, so easy. Y equals 0 minus 4. Y equals -4. And so our ordered pair is 0, because that's what we plugged in for x, comma, -4. And that is down here. Now, this is just y equals 2x minus 4. That's a straight line, and so our final answer, or our graphed function, looks like this. Wow, look at that. Now, you absolutely should not have needed to do this, because, I mean, if you were told to graph, because, you know, it's in slope-intercept form. Y-intercept of -4, slope of 2. Should have been easy. But I asked you to find the intercepts, so this is how you do it. Next, let's find the x and y intercepts of this. Now, if you think you've got what it takes, you know, you've got the brains to do this, you go for it. And then I'll get back with you. Okay? Okay, so fine, the x and y intercepts the following. So plug in 0, so this is x-intercept. Plug in 0 for y and solve for x. 0 equals 9 minus x squared. I'm guessing that this is going to be I wanna add x squared to both sides. How about that? Add x squared to both sides. I bet you didn't think I was gonna do that, huh? Huh? So you got x squared is equal to 9. And then to get rid of the squared, you square root. And then you square root. And you get x equals 3. Am I right? Am I right? Am I right? Well, I'm not completely right, right? If you think, hey, yeah, this is right, then you have forgotten about the plus or the minus. All right, got to keep that in mind. Anytime you square root, you should remember plus or minus, because there are two numbers that when you square it, it gets you 9. Right? Remember, it's supposed to say x squared equals 9. So 3 times itself is 9, but negative 3 times itself is also 9. So there's also this negative 3. So the y values are still 0 because you plugged in 0. So you've got 3, 0, and negative 3, 0. Wow. Wow. You'll have to excuse the vehicle. I'm not good with cars. Whatever that vote that was, whatever, whatever. This is live, so I can't undo the last 15 seconds. So, now let's find the y-intercept. So the y-intercept is, I don't want to use that color. I already used that color. Let's do this nice blue. Y-intercept. Now that is, you plug in 0 for x and solve for y. So you got y equals 9 minus 0 squared. Well, that is just y equals 9. And so you've got 0, 9. Wow, beautiful. Look at that. Now it doesn't actually say to graph it, so I mean, I guess you're done, but I'm going to go ahead and graph it anyway because I'm a go-getter. And so here is my graph. Beautiful. And we can figure that out before we even try to do any of this, because if you rearrange this, for any of you people who remember things, if you rearrange these two, where this is negative x squared plus 9, it'll look like this. Y equals negative x squared plus 9. So it looks like the standard parabola, except it opens upside down, right? It's reflected, and its vertex is moved up 9. So the vertex moved up 9, and instead of opening up, it opens down. Easy peasy. Oh boy, here's your homework. Hopefully you all have enjoyed your first lesson. It only took 22 minutes and 30 seconds and counting. And, there you go. So next up, we'll have 1, 2. So hopefully you have enjoyed. Do your homework. Don't be lazy. I know it's hard. Just try your hardest. And I'll catch you next time.